everyone. Thank you so much for having me. Element 8 team, thanks for hosting me. And there's one thing that I really want to focus on today, and that's the simple truth that engineers and companies simply need more from their process data. The funny thing is, a lot of times I don't even know that they realize it. Well, at least not yet, because they're asking for things, right? They know that they need higher reliability for their storage. They know they need better access to their data. They want easier trending or automated reporting. And they may not even know that those are the things that they want or need, but they can certainly feel the pain points from not having them. And they're waiting for experts like the men and women in the room to show them how to use their data to solve the problems they face every single day. As Lenny mentioned, my name is Jeff Knepper. I am the Executive Director of Business Development with Canary, and I am also joined today by Kyle Kinzinger, one of our partner managers, who's going to help me throughout the demo. And we're excited to talk to you about the Canary system. Now, we know firsthand that end users are feeling the pain of not having the right database solutions because we talk to them every single day. They need help, and we are looking for the right partners to make it easy for them to use that data. So let's face it, when you make process data easy for your customers, their operation just simply runs better, and well, you look like a champion. And I think that's something worth celebrating. But you have to be careful, because suggesting the wrong software, well, that can have some serious consequences. It might seem like free or included software is enough to get the job done, but the wise customer will soon realize that it's not what they signed up for. Or that the very expensive solutions are going to cover all your bases, but you're not likely to win as many bids, be able to get jobs passed through the business side, or not to mention have to worry about wrestling that big old 500-pound gorilla called ROI. Either way, you kind of end up looking bad. But the right software, well, that's money in the bank. You're building out custom solutions that are result-driven, winning more work, and you're creating a fan base that actually pushes work your way. And that's exactly what Canary wants to help you do. And you don't have to do it alone. Both Canary and Element 8 are focused on helping our partners deliver best-in-class solutions and making sure you look great while you're doing it. And you'll love how simple and flexible the Canary systems are to deploy. You can train your team without accruing a lot of charges. You can get the absolute best pricing available on the Canary solution, and you can take advantage of referrals and dedicated Canary and Element 8 sales support. And whatever challenge you're facing, know that we've been there before. In fact, Canary has been helping folks solve their process data problems for a really long time. We started building databases and trending tags before Mario was collecting coins and mushrooms. And since 1985, at Canary, we've learned what works and simply what doesn't. And along the way, we have grown from a small shop in Martinsburg, Pennsylvania, to serving thousands of customers within the United States. And now we work with integrators and end users in more than 60 countries worldwide. We offer sales and support not only from our US-based office in Pennsylvania, but obviously through our strategic partner, Element 8, there in Johannesburg, as well as another partner in Kuala Lumpur, Malaysia. These regional relationships ensure that no matter what time zone you're calling from, you can always reach an authorized Canary specialist for both sales and product support. The Canary solution is a great fit for large enterprises, small utilities, and everything else in between. Our partners are helping us grow very quickly, and we're grateful for their hard work. So what's been fueling all this growth? Ultimately, it's just a simple to use yet powerful automation database that we have built our entire Canary system around. And to further explain the solution, I'd like to introduce Kyle Kinzinger, a Canary partner manager.
All right, thanks a lot, Jeff. So as Jeff said, the Canary solution consists of multiple pieces of software that have been built specifically to solve your client's data problems. And we group our solution based on three main goals or steps that help customers solve their data needs. Step 1, collect and store your data. Step 2 is assigning context to your data. And step 3, maximize your operation. And within each step, there are individual pieces that we'll discuss in further detail. Canary Collectors are the tools that move data into the Canary Historian. And collectors help you reach out to all industry standard protocols, so you can log data directly from your process into the Canary system. Ignition gateways, MQTT Sparkplug-B, OPC UA and DA, SQL databases, CSV files, and web and .NET APIs allow you to create your own custom collectors. And a typical architecture would look something like this. The Canary module for Ignition is installed on the Ignition gateway, sending data to Canary, which historizes it, and in turn can publish that data back to Ignition, as well as to Canary client applications and other applications like Flow. If implementing Canary in situations where Ignition is not the SCADA platform being used, you can collect data from OPC servers. And here, PLCs and other devices are communicating to an existing OPC server. The collector software will be installed on the OPC server and push data across the network to the Canary server, as well as the SCADA system. The architecture would be the same when the data source is an MQTT Sparkplug server. And now let's look specifically at how the data flows through the Canary system. You would install the designated Canary collector and Canary sender applications local to your data source. Again, this could be an Ignition gateway, OPC server, MQTT broker, or one of other multiple options. The Canary receiver service and historian are installed on a separate server or VM. Data is logged from the sender across the network to the receiver, and then checked into the historian archive. Canary client tools and other third-party applications like Flow software, Ignition, etc., can then connect to the historian via the view service and make data requests. So now that you know how data comes into the Canary system, let's talk about the store and forward technology. The sender service is configured to move data across the network to the receiver service, which is matched locally to a Canary historian database for archiving the data. The receiver checks it into the historian and communicates to the sender that the message was received and written to the database. Now, if for any reason the network is not available, or if the historian fails to write the values, all the data will be cached locally. And the admin is notified that you're no longer receiving data into the historian from that logging instance. Then when the connection is available again, we will automatically backfill the data in real time. And the system allows for dual logging and sending data from one sender to multiple receivers and historians, so you can execute any number of local, enterprise, or cloud-based architectures. And we do have a helpful architecture guide that's available to you. So if you'd like to receive it as a free download, just go ahead and raise your hand and we're happy to provide that for you. So the data is being collected and stored. And now it's time to discuss the real star of the show, and that's our Canary historian. The historian is a NoSQL time series database that's specifically built for process data and industrial automation. The historian has been optimized for performance, and best of all, there's no database administration skills required to maintain the historian. And it's highly scalable, so whether you're tracking 100 tags or more than 2 million tags, it's going to be the same software install. All that changes is the licensing. You can dual log to move real-time data to both local and enterprise servers, as well as leverage proxy servers to move data through a DMZ. The historian was designed specifically to meet the challenges of the industrial automation space. And that means whether you're operating inside of a traditional factory, trying to access the data from remote sites with bad connectivity, or just want to account for daylight savings time in your reporting, Canary has you covered. And the system has been built to provide a higher priority on read speeds than write speeds. You only write the data values once, but you could read them hundreds of times. The file-based storage method that the historian uses to archive the data ensures you have the same performance whether you want the data values from the last 3 days or from a point in time 3 years ago. As I said, no database administration skills are required to maintain the historian, and no matter how large the system gets, the performance remains constant and does not degrade over time. You can achieve over 1.5 million tag writes per second, and you can read over 2.5 million tag reads per second out of the Canary historian. So what is a tag? Well, it's a single stream of time series data that we also refer to as points or channels or items, and it consists of TVQ, timestamp, value, quality, but also metadata properties like engineering units or high-low set points. These are all fully customizable data properties. Once the data is written to the historian, it's important to start thinking about how we will compress it in order to keep our data footprint as small as possible. And Canary has developed a unique lossless compression algorithm with best-in-class performance, 3 times data compression. Because it's lossless, we are never interpolating data, never cutting data values. The unique raw values are stored in the historian every time. And best of all, the Canary system is secure. All files are encrypted. All communication of data between the historian and requesting clients is built on top of WCF technology. So this gives you the added benefit of being able to apply both authentication and authorization measures. So in review, when discussing collecting and storing your data, the system is out of the box ready, meaning everything is pre-integrated in the Canary system. Between store and forward and lossless compression, you never have to worry about data loss. And ultimately, Canary has created a database that you can really depend on. Now, step 2 is all about assigning context to your data. And this is where we will examine virtual views, the calculation server, and event monitoring. So a very common problem we see many companies face is something like this, where they have a piece of equipment, a site or a SCADA system, with a tag naming structure that's being followed and written to the historian. But then somewhere else in the organization, there's another piece of equipment or site or SCADA system, and it's doing the same thing, but using a different set of tag names that's also stored in the historian. Now, normally this won't impact production. The operations will likely work just fine with different naming conventions. But it does create big problems when your engineers are trying to generate reports on the data or trend the data or just learn from the data, because they are forced to remember all of these different tag naming structures. So imagine if you could leave the operation alone, not change the PLC, not change the SCADA system, but unify the namespace so that for reporting purposes, all the tags follow a desired format. And the Canary system gives you the ability to do exactly that. You can create virtual views of the data, influencing how the client can interact with the data without altering the data in its physical storage. When reading data from the historian, the view service is the filter that the client looks through to browse, retrieve tags, and read data from the historian. And by utilizing the view service, you can essentially change the way the client sees and interacts with the data inside the historian. You can reshape and alias the tag format inside the historian without changing the historical record. So if you create multiple views of that historical record, then you can offer very specific security-based permissions to the client of how they see data inside the historian. So would the client see the data through filter 1 or filter 2? Well, Canary's given the admin the power to control who can access the data based on what applies to their specific role and the needs of the organization. And this is all accomplished through security permissions or Active Directory login. And the virtual views offers tremendous functionality. The login configurations are fully customizable to fit your needs. So here's an example of how the virtual views can assign context to the data. Inside the historian, we have these 10 pieces of I/O, and we apply a virtual view, and now the client sees a unified naming space. So let's see another example when we look at a second line. So the client still sees the same format, but the tags have retained their uniqueness. Notice as I switch back to the first line. The client sees a structured unified naming space, and the PLCs or devices didn't need to be altered. So the million-dollar question is, how are the virtual views created? Well, regular expressions provide the ability to restructure tag names while maintaining tag uniqueness. And if you don't currently work with regex, that's okay. It's a relatively simple tool to master, and we'll look at it more closely now. The methodology is to first identify and capture the unique parts of the tag name that we want to preserve, and ignore the parts that don't add value. So for example, if you had 3 tags you wanted to reshape with a single find and replace rule using regex, you can do it with this rule. To begin, we want to keep the word line. So we will create a capture group whenever the word line appears by using parentheses. Next, we will create another capture group for the line number. In regex, the backslash and lowercase d matches any single number. This allows you to match the unique number associated with each line, line 1 or line 2, with just a single rule. Next, we will advance past the dot and 020 dash identifier, because for our purposes, it does not add any value to the tag name. We can omit these by choosing not to use parentheses to capture them. When we come to the numeric identifier associated with BL, however, we want to capture these because they represent a unique boiler number. So again, we can use the backslash and D to match, plus use the dot plus as a wildcard to match any number of numeric characters we encounter. Moving past the dash, we will create another capture group that matches on any count of alpha characters up to the next dash. And finally, capture the last instance of numeric digits, ignoring the first digit and the dash PV that's on the end of the name. So now that we've identified the tags and the sections of the tags we want to match on and ultimately capture, we can write the replace rule. The replace rule allows us to recall our previously identified capture groups by using the $sign and then the capture group identifier. So to recall the first capture group, we will write a $1. As a result, we've begun to reshape and alias our archive tag names. And next, we'll add capture group 2 and incorporate the numeric identifier of each line. By adding a dot after the $2, it adds the dot into the tag name and helps to give it hierarchy. Adding the text boiler and then the third capture group will provide a label within the tag name of boiler, and then also display the boiler number as referenced in the original tag. Additionally, adding another dot at the end of the boiler instance creates more structure and reshapes the original tag name from a single parent-child structure into a deeper hierarchy. And finally, we can call the last 2 capture groups and finish the newly aliased tag. Now, if tag names don't have as much logic as you would like, that can be supplemented by reading properties from an external database that might already exist within the organization. So what else can be done with virtual views? Once the tags have been restructured and a unified naming space has been established, you can also create custom asset models. And organizations are likely already talking about equipment from an asset viewpoint. So if you have a site with 3 lines, and those lines are made up of boilers and fillers and water mains, it might look something like this. And notice how line 2 has 2 fillers and line 3 has 2 boilers. So let's see how we would use virtual views to capture all the assets at this particular site. Now that we have a unified naming space with hierarchy, we can use more regex expressions to identify which tags represent different assets and then group those tags into each asset category. We can alias those tag names to provide an easy and clear naming pattern. So looking back at the site example, again, we have 4 boilers, the one on line 1, one on line 2, and 2 on line 3. So using the unified naming space that we've built out, you see line 1, boiler 1, and then the 3 common asset tag names. And the same with each of the other boilers on the other lines. Common tag names with unique identifiers show you exactly where the asset is and what else it impacts. So what's the benefit of all of this? Well, beyond giving you better organization, it gives your team the ability to make specific requests based on asset types. For example, show all boiler temperature tags. More specifically, it helps automation experts automate their workflow. Filtering based on asset tag conditions means you can immediately see all boilers with a temperature that's outside of a desired range. So there's real power in the ability to automate the workflow and easily use processed data. Clients are no longer hunting for information, but can instead quickly generate reports with the information the organization needs. Now, it is key to point out that models do not break if the assets don't match up perfectly. And if organizations are working with a dynamic process and constantly bringing assets online or offline, the virtual views does look for tags to be dropped out of the historian, and it updates the model automatically. So now that we've looked at virtual views, let's go ahead and move on and examine another way Canary can assign context to your data, and that's through the calculation engine. So that's where we can look at raw data, condition-based data, and calculated KPIs. It's powerful because you can deploy a single calculation to all instances of an asset type. It runs in real time while also backfilling, and more than 70 functions are available. So if we look at the asset tags of a boiler, we see there's a temperature tag. So every 5 seconds or 1 second, it's pulling to get a new temperature. We can run a calculation anytime there's a boiler, ask it to use the temperature tag to give us an average 60-minute temperature for that tag. For the fillers, we could use the out bottle count and out bottles rejected to determine the percentage of rejected bottles. And the water main accumulation and flow tags could tell us the total daily volume per line. And just like you can do condition-based tag calculations, you can also key off those calculations to monitor asset health. You can create a series of logic or rules to determine whether an asset is in an alert state or not, and then do reporting and pull analytics based around the events. So event monitoring provides condition-based asset monitoring, reporting based on event performance, as well as analytics. Constructing the rule is the trigger for the event, and a simple rule would be to trigger the event if the level of a tank gets below 25% and the temperature of the liquid falls below 80 degrees. And so we did this with simulation data, and here's what we got back. So you see the list, you get the source, the start and end time, the duration, as well as analytic properties associated with the event. And this information is customizable and can be tailored to your needs. So that wraps up step number 2. And now we'll focus our attention on maximizing your operation. The third step is where we examine the Canary client tools, which include Axiom, the Excel add-in, and we'll take a closer look at the publisher and connectors. The most robust client tool is Axiom. It's our trending, dashboarding, and reporting tool. It's built with HTML, so it works with any modern web browser. It's accessible from a cell phone or a tablet out in the field, as well as your desktop or laptop machines. It's designed for self-serve reporting. So Axiom changes the traditional model of the client asking the SCADA team to produce a trend chart and makes it easy for the end user to produce their own trend charts. First and foremost, Axiom is an advanced trending tool. You can build your own trends, run ad hoc calculations, perform statistical analysis based on time interval. Charts and applications can be saved publicly, privately, or in read-only mode. and you can publish automated reports via email with ease. Here are a few examples of charts that have been produced within Axiom. The versatility of Axiom allows you to build HMI-style dashboards and reports in addition to trend charts. The drag and drop editor makes building dashboards a breeze. And from gauges to symbol graphics, tables to trends, Axiom really has it all. And asset templating with condition-based filtering means you can effortlessly monitor your asset health. So here's a few examples of applications that we've produced within Axiom. It's easy to incorporate trend charts and tables of data. You can also add things like donut gauges or spark lines. Or you can build applications that are less about trend lines and more about looking at data tables or graphs. Basically, Axiom is a blank slate that allows you to build out and customize whatever it is that engineers and decision makers need to visualize. The Excel add-in is another great tool in the Canary system. We know that many members of your team are probably already using Excel, and the add-in allows you to connect your Canary data to Excel. This helps quickly solve reporting needs and gets raw and aggregated process data out of the historian and back to your customers. And it also gives the ability to build event monitoring on the fly. So here's a quick example of how easy the add-in is to use. You can see how you can get a tag list, and these are level percentage tags we'll put in column A. Then just click the last value, and just like that, in only a few clicks, you have the last known value for more than 500 tags. And the Canary system makes it easy to get data out of the Canary historian and into other systems and pieces of software. That's where the connectors help. And Canary connectors can include a custom connection to Flow software, another connection to move data back into Ignition, as well as an MQTT publishing client, 2 different APIs, ODBC connector, if you need to expose a Canary historian in a SQL-like manner to make queries against our database, and OPC HDA server speaks directly to our historian. So that wraps up the 3 steps of how the Canary system can make it easy to use your process data. We covered all 3 steps, and now I'll toss it back over to Jeff and he can wrap things up.
Great. Hey, I appreciate it, Kyle, and great job. Well done, sir. You covered a lot of material and you stuck to 20 minutes. That was great. All right. So as Kyle mentioned, the Canary system does include everything we've discussed today. And so you purchase the system as one complete piece, prepackaged and integrated. And it includes the collectors, the store and forward component, the historian with 100 tags, the virtual views, the calc server, the events, even a single license of Axiom and the Excel add-in, as well as every Canary connector that you need to get started. The only thing we license are the number of tags for the historian and then the number of users. We want to be very transparent with our pricing. So anytime you visit our website, you can use our pricing calculator to build out the system of your needs. You can even download our entire price list. Note, the pricing calculator does not include partner discounts that Element 8 is happy to pass to you if you become certified on the system. If you want to build out your own pricing, the first thing you need to decide is who's going to host the data. Either you can host in your own on-premise or in your own managed cloud solution, as Canary can be installed on any Windows VM or server, or you can choose to host the data with us in our Canary cloud. Next, select the exact number of tags and clients you need. We'll go ahead and build out an example here for you. This is just a base solution with 100 tags and a concurrent client. And you can see that if you want to host it on-prem or in your own instance of a cloud server, it's $4,000. Or you could choose to subscribe instead of paying the upfront cost for just $135 US per month. Maybe a bit of a larger system. Since tags are only priced at $1.50 per tag, additional tags can always be added to the Canary system in any numeric number of those that you'd like. So you could do 5 tags or you could do 527 tags. Here's an example of a 5,000 tag system with 3 clients. As you can see, even as you scale it, because of the low tag price, the system stays very affordable. Additionally, we can go unlimited for both tag count and clients on any Canary server, as well as we have enterprise licensing agreements available for the larger enterprise solutions. All right, so how do you get started? You've liked what you've seen, you think this makes sense. Well, step one is to start with a proof of concept. And through our partners at Element 8, we offer a free proof of concept for 90 days. In fact, I just turned over to Lenny last week a large batch of POC license. So please see him. He'd love to get you started on a proof of concept. Once you've tested the Canary system, you can purchase it directly from Element 8. And finally, when it comes to training and deployment of the system, Element 8 and Canary will combine forces to offer free support for the first year after purchase. After that, Element 8 and Canary provide technical support, software maintenance, and version upgrades through an annual support and maintenance agreement. That concludes everything that we have today to present to you. I hope you really enjoyed learning more about Canary. We would love to walk with you through a proof of concept and hopefully through the team there at Element 8, be able to show you how easy it really can be to use your process data. Thank you, everybody.